This video will be discussing half-life. So many of you may have heard of the Chernobyl incident, a nuclear power plant. It melted down in 1986. And then it took until 2012 to safely re-enter that zone. And the reason why we were able to safely enter the zone is because we knew how much of that radioactive material was still present in the air by using our knowledge of half-life. Okay, so half-life is the amount of time it takes for half of a substance to decay. And in chemistry, you'll probably recognize half-life when you're talking about elements, because elements have half-lives, and I believe that's on the periodic table. Okay, so let's look at this example. A form of DDT pesticide was banned in 1972, and DDT was used on particular crops during the 70s, or earlier than that actually, in the 50s and 60s, and then we realized how dangerous it was, so it was banned. But it's still in the air, it was still in the soil. But it has a half-life of approximately 15 years. So that means after 15 years, half of that substance had decayed, okay? And we want to find out how much DDT would still be remaining after 72 years, okay? So that's a long period of time. But if we're thinking about this in terms of time interval, after one time interval, 15 years have passed. After two time intervals, 30 years have passed. After three time intervals, 45 years have passed, and then 60 years have passed after the fourth one. So, and then after 5 years, if you think about that, between 4 and 5, then we get to 75. So it's a little bit higher, or 75 is higher than 72. So we know somewhere between 4 and 5 intervals, this has been decaying, okay, for the sake of the problem. So if we started off with 400 pounds, we're taking half of that. Sorry, if we started with 400 pounds, then after one time interval, there'd be 200 left, right? Half of this amount. And then to the next interval, we would have 100 left. And then to the next, we would have 50 left. And then we would have 25 left. And then we would have 12.5 left, right? We just keep taking half of it, half of it, half of it. So my next question is, how many time intervals occur in the 72 years? So how do we think we can get that? What we can do, we can take the number of years, 72 years, and divide it by the half-life. Okay, so we have 72 divided by 15. I'm going to go to my calculator, 72 divided by 15. And we're going to get 4.8. So 4.8 are the time intervals that have gone by. Okay. So the exponential decay model we're going to come up with. Okay, so y equals, and we initially started with 400 pounds, but we're taking half of it. So our multiplier is 0.5, or 1/2, to the x, where x equals the number of time intervals. Okay, so from here, the number of time intervals that have gone by in the 72 years, 0.5 times 4.8, we get to see how much of this DDT is still remaining. So on the calculator, 400 times 0.5, and then raised to the 4.8. And so we have 14.35 pounds. Remaining, okay? So that's still a lot of material. So usually it's a safe area again. I mean, this is minor compared to like the 400, right? It's a small amount, but that still means that there's this pesticide that's still present, and 14 pounds of it to be exact. So let's do another one. A radioactive material has a half-life of 32 years, okay? How much of a 700-gram sample remains after 240 years? So we want to figure out what the number of intervals that have gone by. Number of half-life intervals. Okay. So there were 240 years, but the half-life is 32. So we have 240 divided by 32, and we get 7.5 intervals. Okay. So here comes our exponential decay model. We're starting off with 700 grams, and then our multiplier is half, right? We have a half-life. Everything's halving in each interval that we increase. So when we plug that into our calculator, we get 700 times 0.5, close parentheses, and then we're going to raise that to the 7.5. And we have 3.86, so the nearest tenth of a gram, 3.9 grams remaining. Okay, so notice for a half-life, the multiplier is always 0.5, just to keep that in mind. So now you're going to practice some of these problems for homework.